Always a pleasure.
Always a pleasure. So what are we doing?
What are we doing? We're introducing the group as well as yourself.
Yeah.
So good evening, everyone. My name is Sam Nasser. This is the Cleveland C# VB.NET user group. We meet here every fourth week of the month. The meeting space is courtesy of DeVry University, and the pizza and pop are courtesy of Inedo, makers of DevOps programs like Buildmaster. The meetings are free of charge and open to the public, and we discuss anything and everything related to .NET. And one of those things related to .NET is SQL Server. And luckily, sorry, I'm blocking the title.
You are blocking the title.
So we're lucky to have Sarah Dutkiewicz, also known as Saduki. She's going to be discussing what it's like to be a polyglot scientist, dealing with R, Python, and SQL Server. Sarah's been an MVP since 2009, is that correct? Actively involved in the community. You can always find her on Twitter, and she's always at one conference or another constantly, despite the 2 kids and a husband at home.
Yes.
And she started Cleveland Tech Events, which is a website for all the local tech communities in the Cleveland area and Northeast Ohio. I'm sorry?
You just put that down in 2017. I feel kind of have to because, well, WordPress plugins and changing their pricing, it got to be too expensive. I couldn't maintain a calendar of over 60 different technical groups in the Cleveland and Akron and Canton areas.
Okay, so she used to manage Cleveland Tech Events. In any case, the meeting will go for about 2 hours. Then afterwards, we meet over at Slyman's, and where we network, have some conversations, and maybe a drink or two. So, without further ado, I'll turn it over to Sarah.
All right. How are you guys doing tonight? All right. As Sam introduced me, I am Sarah Dutkiewicz, also known as Saduki. So if you're on Twitter or Facebook, LinkedIn, any of the social medias, you can probably find me as Saduki on there. And my contact information is on the slide. So before we get into the details of what's in the talk, I just want to know a little bit more about you all. So how many of you use SQL Server? Okay. Python. Any Python folks? Some. Ish. Okay. Anybody using R? Okay. Great. For those of you guys who are working with Python or R or SQL, are you guys data analysts or software developers? What kind of job titles are you looking at? Thereabouts. Yeah.
4 of us are students at Tech Elevator, so none of us are employees yet.
That's I just talked to Andrea at lunch today. She mentioned that Tech Elevators are here. Excellent. Well, welcome. And
I'm on the database side.
Okay.
I'm just interested in R.
Hi.
Hi. Come on in.
Yeah, thanks.
It's your seat.
There. I'm sure we can probably pull this away from the printer. Maybe. Yeah. So just to make sure, you are here for talking about our Python and SQL Server. Okay, you're very close. Okay. So just to be clear as to what we will not cover, because there's a lot to be said about data science and R, data science and Python, data science and SQL Server. There's a lot for those who don't know what data science is. How do we calculate these? What do these terms mean? So there's a lot that could be said. There's only so much time. I only have so much in my brain at the moment. So we're not going to get into the theories behind data science and machine learning. We're not going to get into that. We're not going to deep dive into either Python or deep dive into R. If you have a solid knowledge of these, I will point out little things here and there. If you're just getting started, I will also point out more things here and there just for you to take in. But I am not going to deep dive into the basics of Python or the basics of R. You can do that outside of here. If you need resources as to where you can learn more about either of those, I can also walk you through. Like there's a try Python, there's an R tutorial, various R courses on Coursera that I've gone through. So plenty of resources out there. We're also not going to go into SQL Server in a deep dive into that. Again, so many hours. There's a user group dedicated to SQL Server as well. We'll save the deep dive for another time. I also need to let you guys know that there is a data science virtual machine available on Azure. And I'm not going to cover it in this presentation. The only reason why I don't cover the Azure virtual machine in my presentation is because there's no guarantee that the internet will work. And so all of my demos are going to be running locally on my machine. When I show you the different things that we're running, it can also be run in the cloud, various different compute contexts, so it is scalable. This data science VM is great to play with on your machine on your own time. But again, this is something I don't show during demos because internet connection is never guaranteed. So what will we cover? We're going to talk about the problem with being a polyglot, because there is a slight problem with that. And we're going to talk about why you would want to bring R to SQL Server, or why you want to bring Python to SQL Server. What's the big deal with it? Why did I get so excited about this in the first place? Well, if you came early, you heard me mention, I like taking languages, whether it's they're Microsoft-based languages going on non-Microsoft platforms. So back in 2008 and 2009, I was talking about running Iron Python on Linux. I'm like, okay, Iron Python, Microsoft's implementation of Python on an operating system they don't deal with. That sounds pretty absurd. I gotta go explore. That's what this started out for me was, okay, playing with data and bringing R or Python to SQL Server. And you'll learn about, I'll show you my data set and tell you more of that story here. But we will cover what does this solve. We'll take a look at the introduction of how do we bring R to SQL Server, how do we bring Python to SQL Server, to talk through some of the SQL. No, I don't have these up on SlideShare just yet, but after the talk is done, I will upload this to slideshare.net/Dutkiewicz. I will give Sam the link. I will also post the link in Meetup. That way you guys have access to the slides. My goal is to also get my SQL scripts up on GitHub. That way, if you want access to the SQL, they're there. Rest assured, I am not a Microsoft salesperson. Yes, I'm a Microsoft MVP. I'm a most valuable professional. What does that mean? They just recognize that I do stuff in the community. They are not writing me a paycheck. I have loved data, I guess, most of my life. Been in the field over 20 years now. And even before I got into the field, it was one of those where I was like, okay, I need to keep track of addresses. Create it in an address book and Access. Learn how to go Access to Visual Basic. From there, I had an internship where a guy saw my potential and said, hey, you like data, you should see SQL Server and Oracle. So for me, that love of data started early on and has carried me through. Go through fits and spurts of working with it at work. Got into a spot where I was in a teaching role for a while and said, I want to be more technical and I want to play with the tools, not so much worry about teaching, so what could I do for a hobby? I went back to playing with data again. And of course, like I said, I've been in tech over 20 years. I say I've been in tech and not been a programmer because I've got the IT background, I've got the tech support background, I've got the web developer, the desktop developer, the course administrator, DBA. Yeah. I wrote a weird gamut like that. Also, I am a practitioner and a hobbyist. I put these into play when I'm in the field, when they pay me, and I also do this for fun. But I am not a researcher. I'm not one, I let the people who like doing the research, I'll let them do that. I want to play with it. So I'm not going to get into theories for that. Alright, so I got to tell you about this wonderful data set. Sam, where's my endpoint here?
Right there.
Right there,
Yeah.
Okay. Just so I know, your camera. Alright, so this here is some sensor data. So at my house, we have a bunch of Raspberry Pis with temperature sensors hooked to those Raspberry Pis, reporting back to a database with a timestamp. It's telling us the sensor name and the sensor value. My husband's been running these out. This is from 2016. I also have 2017 and 2018 data available. Currently, I have the 2017 data through June available on GitHub for R, but I'm going to be making all of this available at the end of the week, probably end of day tomorrow, so that you guys can see just how messy this data set is. Right now, it's a fairly flat table, other than there's these IDs, which means that there's a censored table somewhere else. But we also have the sensor in here. My husband, he's an IT guy. He's a networking guy. He is not a normalized data guy. He just put all the fields in there, and I go, oh, that's gross. I don't want to see it. And so I saw this, and he's like, yeah, I wish I could graph it. And I'm like, I was going through an R workshop. I could probably do this with R. Show him, and he's like, how did you do that? I'm like, I'm the dev, you're the hardware guy. You keep setting up your Raspberry Pis, reporting back to the databases, let me play with the data. So my goal was to play with the technology while playing with this data as well. And so initially it was in MySQL and using R. And so you can see that I could look at the data and go, well, we have sensors were getting knocked offline, and the different sensors could tell if they were getting too hot, too cold, something like that. So I was just using R's, got a bunch of plotting libraries, ggplot, I believe is what I was using to build this. He's like, oh, you got colors. And he's like, how did you? And I'm like, my R workshop at CodeMesh last year. Now, I'm a polyglot. That means I know and I use several languages. As I mentioned earlier, C# and Java are my enterprise languages. If I'm working at a large customer, those are typically my go-tos. Also done Python, Ruby, Perl, JavaScript, HTML, CSS, and then also played with a bunch of other ones. Presented on Squeak, which was based on Smalltalk, which a lot of people liken to Scratch, because Scratch was built off that. So I'm a polyglot who has a language problem. If you guys saw A&E Hoarders, if there was an A&E Hoarders programming language edition, I would totally be on. Guilty. But the reason why that is because I see programming languages much like somebody, like a craftsman would see their tools. Different languages are capable of doing different things. Different languages have different strengths. And for me, if I'm dealing with data and trying to process it and analyze it, R is something that has been on the forefront, and that was something I looked at last year at CodeMesh, which is a conference in Sandusky in January. So I kind of gravitated toward that. Python is also strong, science, math, and numerical munging of data. So we've got R, we've got Python, and we've got SQL Server. SQL Server doesn't have a cool logo. Not anymore. So the title of my talk, I talk about being a polyglot data scientist. I use the term data scientist very loosely, so if there are any actual data scientists in the room, I apologize ahead of time if this offends you. Just fair warning, again, practitioner, hobbyist, but a data scientist is essentially somebody who's going to analyze and interpret complex data. They're going to be able to take that massive data set, or that gross-looking data set, and make it into something that people could actually make sense of it. This is what we do. And ideally, when you're manipulating the data into something that people understand, they can see that data and then make business decisions off of it. Or in the case of our sensors database, my husband can see where there's different issues with temperature, and then can account for that. One of the problems that he saw when he looked at my rendering the data was that my office was very cold. Been complaining for months, and now I actually have the data to show him that. And so that led him to getting another sensor for our thermostat, so that we could even that out, because I am at the other end of the house. So this data actually proved useful, because I was able to say, look, it's cold in my office. And he was like, well, cold is a relative term. I'm like, yeah, low 60s, that should be in mid to high 60s, cold. 50s, cold. Listen, I'm a dev. I love my hoodies. Yes, I love those hoodies, but really, I shouldn't have to wear them in the summertime either. Yeah. All right. And when I say data science, what do you guys think of when I say data science? What comes to your mind?
Slicing and dicing data.
Slicing and dicing data. No, I'm not going to redo that again. You caught that on camera the first time. Good try.
Wasn't going to say anything.
You didn't have to. Sam and I have known each other for years. All right, so slicing and dicing the data, yeah.
Turning the data into the graphics like you did for 4 slides ago? 5 slides ago?
4 slides or 5 slides ago. Yeah, so changing the data into visualizations. That's something that happens. What else? Yeah.
Organizing very large quantities.
Organizing very large quantities, yeah. Statistics. That was one of the first things I was like, I want to go down the data science route. This is awesome. I had statistics in college and hated the course. Absolutely did not like it. Because I had a professor who just couldn't teach it well enough and didn't make it exciting. It wasn't until I went to that R workshop at CodeMesh last year that I had the aha moment. I was sitting there typing these R commands and went, I know what this means now. I know what this means now. Where was this when I was in college? Wasn't there then. So statistics. What else? See a hand back there?
Predicting what data you will need next.
Predicting what data you'll need next. Now, predictability does come into play, yes. Data science does encompass all of this stuff. Data science is a lot more than that. So statistics, of course, is one of the first ones that come because you're doing data modeling, sampling, you're trying to see the trends, trying to see the predictability of your users. Common databases that you'll see in data science samples include things like irises and how they grow, and the different petal shapes and what to expect and what you could probably predict off of that. Another example that they use for this particular product is New York City, and I think it was subway rides and taxi rides, and so they have some test data out there as well. I'm just seeing those trends using statistics. Mathematics, again, related, similar to statistics. So you're going to see the NSA, the astronomers, and military folks. Data science, another subset, is data engineering. So you get into things such as how is the data coming in, how's the data going out, does that process look right? File optimization, Hadoop clustering, things like that. Machine learning and algorithms is a subset of data science. So you'll hear the term machine learning, so that it's part of data science. There's also a business component to data science. So data science itself, it's one thing for us as software developers or as engineers to look at data and say, I know what it means from our own perspective. But if we were to take that data and go, this is what I got, the business will look at that data and go, okay, your understanding of that is one thing. You being able to draw that out, we make sense of it. But now as the business, we have business domain knowledge that a lot of software developers don't necessarily have right away. The business for data science, they're focusing on the decision sciences. How do you make decisions based off of that data? Then it goes to what Dan mentioned with the predictability. That comes on the business side as well. Because the business has to be able to look at the data and go, okay, what decisions can we make from this data? They also need to be able to look at the visualizations like what I showed and look for outliers to go, okay, what use cases are we accounting for? Does it look like it's trending like it should? And why is there an outlier? What did we not think of? So data science, the study of the data itself. You have software engineers who are focusing on data science. And the ones who are doing data science related stuff are polyglots. They're people who are understanding the various platforms out there, various databases out there, whether it's SQL Server, Postgres, MySQL, whether it's the NoSQL stuff, if we're going MongoDB, CouchDB, if we're going into things like Hadoop. Any of those, they all get into play as well. Visualization. There is a science behind visualization itself. You heard of, I believe his name is Edward Tufte. He's got a whole a book and theory behind visualization that all the visualization experts have been talking about. That's the one to look into. So how do you choose how to display your data? And how do you present your data? And that's part of knowing your audience as well. There's the spatial awareness of data science. And of course I have the link on the slide. And again, these slides will be available on SlideShare. There.
Good recommendation for Edward Tufte. T-U-F-T-E.
Yeah.
I had a chance to attend a lecture I knew of him, and because of that, I was very excited to go to a lecture by him at the Cleveland Clinic.
Oh, cool.
And he had a freebie for everybody who came, all 3 of his books.
Oh, wow, that's awesome.
And if you've not heard of this guy or read this guy, it's very, very interesting. He approaches visualization without any technology whatsoever. His big claim to fame is graphics highlighting an existing map of the invasion of Russia by Napoleon. It's pretty far from modern technology, and he shows degrees of freedom and all of this stuff. It turns out he's not a very pleasant character.
I've heard that he's not a pleasant character.
He's a real screwball. Really, not a screwball in a pleasant way. He's kind of a mean guy. I mean, he said, I'm going to end my lecture and leave. Thank you very much. Goodbye. I'm leaving 15 minutes early, which is what you all want. He got really very cold and everything. But his books are fantastic to take you away from all the technology we've all acquired and approach the problem of visualization in a way that nobody else has. So big thumbs up for that part of the tough world.
Yeah, and his last name is Tufte. That's why I was like, Tufte, how do you pronounce it? My friend Dave GR, who is now out of the Chicago area, he does a talk on Tufte and the visualization and how that applies to us in the programming space.
Oh, it's
phenomenal.
First name is Edward.
Edward. Now, the problem with being a polyglot is that you know so many languages, you know so many things in your tool belt, you want to use all the tools, and especially having students in the audience, you guys understand you're learning a new language. What do you want to do with that language? You want to apply it everywhere. You want to learn it and push it everywhere. So being a polyglot, it's hard when you have all these tools and you're like, oh, they're all nails. I have this massive hammer. I have a whole belt of hammers now. How do I choose which hammer? How do I know what is good? So the problem is that knowing what is appropriate is a good thing. But what happens in a case like this where you're like, okay, I have data that I need to process, but the data lives in the database somewhere. The database in this case was MySQL, but I moved it to SQL Server because product and demo and fun. So for me, it was a matter of figuring out, do I bring my data to my computation? So do I stay in R? Do I stay in Python and then call in the data that way? Do I export my data to a CSV and then import it in Python and use pandas for it? Do I use R and the various libraries, ggplot and such, and bring in a CSV that way? Or put it in GitHub and pull the GitHub data set that way? I could do that. But then when I realized that there was a tool that I could use that will allow me to bring my computation to the data rather than moving the data around, and I don't really have to do much other than making sure that the packages are installed on the server, I was like, okay, if I'm not having to move my data and bringing the computation to the data rather than the data to the computation, I think this is worth exploring. Again, multiple tools, multiple solutions. How many programs do I really have to use? How many steps do I really have to take? And how can I deal with it if there's just one tool? And that's what this was allowing me to take a look at. If you guys have questions at any time, jump in. All right.
So are you going to give an example of how you took the data to the server? Cool.
So what we'll do is we'll talk through some of what this has to offer, and then in the demos I'll go through the introduction of how this all works. Then we should be able to see some of the sensor processing as well, provided everything's cooperating. All right. So what do R and Python have to offer for SQL Server? Well, if you think about SQL Server, a lot of hands with the SQL side of things. Can you really do visualization from SQL Server by itself? Not really. You can write queries. You could do some ASCII art. I've done some horrible queries. The DB gave me yells at the developer, me going, "Don't do stupid stuff like that." But when you wanted to do quick visualization, can't really do much in the way of data exploration. You could do a high level, let's do some select queries and go and see what's going on, rather than trying to flip it around every which way. It gets kind of gross with joins and unions and mixes of unions and joins and subqueries, and then you're going, I just did what? That's kind of gross. So R and Python, they have libraries that make it easier for us to do visualization. It makes it easier for us to flip data around, manipulate it every which way. Statistical and math analysis. In terms of SQL libraries, it's not really there. You want those kind of computations, you really have to deal with R or Python or some other language in that space. Observing trends, again, you can see some trending in queries. Suppose you could say, okay, select and then do some groupings and such, and then watch the trending that way. A lot of manual labor, a lot of that. When there are libraries out there to help make it easier, that's what you want to use. Regression, and going back to trending and statistics. And if you can bring these libraries right to your data, it's going to be usually a quicker exploratory analysis. So rather than, okay, I have my data in a database, so I got to make sure, do I have my Python libraries to connect to that database? If I don't, can I at least get the data out of the database into a format that I can manipulate with Python? Yeah.
Maybe this is a silly question, but most of the things you mentioned you can do if you just pop the query into Excel. You can do everything you mentioned with Excel. That's why and it does most of the heavy lifting for you, right? It says protocols for regression and trend analysis.
It does.
About 100
Put a
million.
terabyte of data in Excel and see what happens.
I was going to say,
Put a what?
It's very limited in terms of how much data you can store. Versus, so if you're talking, typically for these things, what I'm going to show is local on my machine, so I'm not talking about terabytes and gigabytes and terabytes of data on here. I'm only working with megabytes of data. But we're talking big companies, Fortune 500 companies, lots of data. We're talking companies who've been around for years, so that's years of lots of data and doing all that trending. That's where you're going to need to do something, and that's why things that I'm going to show you tonight, I'm going to show locally, but I'm also going to point out that there's going to be things that talk about compute context. You can either run it locally if you think your machine can handle it, or you can push it off to the cloud or to Hadoop or to somebody else to do that processing for you. So you'll want to choose the right compute context for however much data you're dealing with. This poor machine here, I think, would melt under terabytes of data. Gigabytes, on the other hand, probably okay. Just very slow. So yeah, Excel could work with SQL Server directly, and I'll give you that. It does the visualization and stuff. For small projects, I actually use Excel. So if I was cringing at it, it's one of those. It reminds me of like using Access for database work. It's good for small projects, and I wouldn't use it for large projects. Little quick one-off sample demos. So rest assured, there's no Excel going on in here tonight. But yeah, if we're working with large tables, and especially if you have something like the mess I have, where it's one large table, and I want to look at it in different directions and see different angles of, okay, what's this trend, what's that trend. Python and R are good for doing those exploratory analyses without having to work with the data separately and bring it. This tool allows us to bring it in. I'll show you. Which is nice because if it's quicker, I can start going and going, okay, how does this data trend? Okay, now let's see, what is this trend? Okay, what is that trend? Is there a relation between these types of data? I can easily start going down a direction, switch, and not have to worry about, okay, now I got to reload the data or I have to reload my context somehow. It's easy to just bring that stuff in. This particular data set that I'm working with, this is a smaller data set. This is the 2016 through June of 2017. So there's about 400,000 observations. It's just one table. And the questions that we had with this were, what are our temperature trends? What are our sensors going offline? What temperatures, like, we have a goal for what temperatures should be in what rooms. And where do we see inconsistencies in our sensors? Something that we learned recently with our sensors is that they have a certain battery life, and they notify us when the battery is low. And we've noticed that when the battery is low, that the accuracy kind of goes down a little bit. So, things we've learned over the years. I mean, the whole reason why we started with the temperature sensors is because we had chinchillas. And chinchillas, they have to be kept about 72 to 75, so there's a particular range of temperature that they work well with. You didn't want to get too cold, and you really didn't want to get too hot. They're like little toddlers in fur coats. So it was one of those, we had to watch our temperatures for that. And then shortly after that, then we had kids, so watching the nursery. Now we don't have chinchillas, now we're just down to kids. And I don't plan on getting rid of them anytime soon. They're 3 and 5, so kind of stuck with them. So what we're going to look at is bringing that computation to the data. Alright, so we're looking at SQL Server 2016 and SQL Server 2017. How many of you guys are playing with 2016 or 2017 at work? Okay, I see some. How many of you guys are playing with it at home? I can see all the hands. Yeah, that's awesome. Alright, so if you want R services, if you want to play with R on SQL Server, that works in SQL Server 2016 or SQL Server 2017 with this tool called SQL Server R Services, or you may see it called Machine Learning Services. So it went by a couple of different names, but it was just for R in 2016. And SQL Server 2017 on Windows, all these pre-qualifiers now, it's SQL Server R Services, Machine Learning Services, and Python support. SQL Server 2017 for Linux is out, but when I checked with this stuff back in November, this support was not there yet. I'm talking with a gentleman at CodeMash, it still wasn't there yet. So, hang in there if you're running SQL Server on Linux, coming down the line possibly. But for now, SQL Server 2017 on Windows, you can use machine learning services to get this working. I'm going to be running on the client side, which means I'm only working with machine learning services. If you're working on the server side, they also have something called Machine Learning Server. The entire suite is now under what they call Azure ML, Azure Machine Learning. So all these different names that you're going to see as you're trying to play with this at home. Machine Learning Services seems to be the common one that I find a lot of tutorials on that makes sense. It's Microsoft. If you don't like the name, wait about another 6 months, they'll change it to something else. How many links can we have? L-I-N-Q, L-I-N-C. Alright, so when I was talking with my husband about this, we were like, well, we can use Python or R to manipulate the data. And I'm like, and I could just use it out of my SQL, which is what I was doing at first. And I'm like, but new project, gotta play with it. It sounds absurd. Why not? Let's bring it into SQL Server. So we import the data into SQL Server. The R part for, in general, R server does exist for Windows, for Linux, for Hadoop, for Teradata, but on Teradata it is not as machine learning server. Anybody working with Teradata? Ah, finally, I meet somebody who's working with Teradata. Awesome. So it's just called R server for Teradata. It's not called machine learning server. For the others, you may see R server for Windows, you may see machine learning server. Or R server for Linux, or R server for Hadoop. So the R itself is cross-platform. We're going to use SQL Server as our base. And I'm going to say R and or Python on top. If you prefer one or the other, that's fine. If you want to run separate scripts in the same query window, that is fine as well. So if you're like, my mind can think in both languages, I think better for this particular function in R, and I think in this other function in Python, you can do those in the same query window, that's fine. It's just two sort of procedure calls. Just so you're aware, so we're going to look at the client services. They also have Microsoft Machine Learning Services. It has something called RevoScale R and RevoScale Pi, which I actually have slides on those a little bit as well. Alright, Microsoft Machine Learning Services. Rest assured, demos are coming very shortly. So, Microsoft Machine Learning Services and SQL Server. 2017 is Python support and it's scalable. So you can test on a single machine. That's what this guy does, and then deploy to the cloud. For SQL Server on Windows, Hadoop, and Spark. So in database is what I'm going to be showing, and that's running R in database, running Python in database. I have SQL Server 2017 installed on my machine here. The way we do this is we install our SQL Server. When we install our SQL Server, you also want to install the machine learning support. They also have specific checkboxes for R and for Python. You're not going to need to open an IDE and SQL tools to accomplish this work. No context context switching needed. You could do this all in SQL Server Mannequin Studio, which is what I'm going to show you. You could also do this in Visual Studio. So if you have Visual Studio and you have a database connection open, you can open your query window in there and run that as well. I've had issues with my particular version of Visual Studio. I just recently updated it. I haven't tested it, so we're going to use SQL Server Management Studio here. Mostly because I don't trust the demo guys. Some things to note. How do you know if you want to use Python or R? Let's say you know both of those. How do you make that decision? What version of SQL Server are you working with? If you've got SQL Server 2016, your choice right now is just R. If you're doing SQL Server 2017, you can use either or both. So what are you familiar with? If you're not familiar with either of them, but you want to learn them, look at the tutorials and see what makes sense. If you want to learn Python, there's a book I recommend from Manning called Hello World. It makes Python very approachable and easy to learn. In terms of data science in Python, I have some links at home that I can also post in the meetup as well. And then something else you need to consider is what features are you looking for and how are they supported by Microsoft ML. So something I learned while playing with this is that not all the Python libraries that you use may be available. So that's something to keep an eye on. I'll show you how to find that too. We'll look at that in the demo. So for those of you working with Python, know that the Python that we use in this is CPython 3.5. I will have a script in there to show you that. Revoscale Pi is the Python equivalent of Revoscale R. It's a library, and I've got a slide later on that. We'll talk about it a little bit more as to what it does. It allows us to do the computation in a scalable way that I can test it on my machine and then change the compute context. Say, okay, my test data might be local, my remote data computed on Spark, elsewhere. So yeah, Python, of course, is the remote compute context support. Also, there are some familiar libraries. So if you're familiar with TensorFlow, is a big one nowadays that you hear a lot about. There's scikit-learn, Cafe, and then Peano or Keras is another one of the Python support that it does support. Okay. And I'm going to jump over to Management Studio. Can you guys in the back see this okay? All right. And sorry, camera, I am just a voice. Okay. So I'm going to maximize this a little bit, maybe. Let me get rid of my data. I don't want to see it. Okay, maybe not. Alright. Just so you can see, so I am running SQL Server 2017 on my machine. It's about a SQL Server 14 SKU here. I have a couple demos here, which I will make available to you guys as well. I originally started this with our demo and a Python demo as separate databases, in case there is sample data to play with. As you can see, our test data migrated into Python demo, and eventually I was like, yeah, we'll just use CP test. I also have in here the AdventureWorks 2016 and the Wide World Importers. These are two of the sample databases. So AdventureWorks, if you've been dealing with SQL Server for a while, you're familiar with this beast. Wide World Importers is new as of 2016, 2017. It's fairly new. It's a newer data set to play with. And I grabbed the DWs, the data warehousing ones, for a little more data, a little more shaping. Let's see. So I'm going to go ahead and pull off my R demo Hello World, so you guys can see what this looks like. So this is just a simple, I'm going to create a variable, I'm going to call a SQL statement, and I'm going to store the SQL result in that variable. So what we have here is your SQL use database statement. And then we have a stored procedure called sp_execute_external_script. This stored procedure is what we're going to use to execute R code and Python code from SQL Server Mannequin Studio. First parameter we're using is language. For this one, we're using R. Our script. This is just a simple script where I'm going to have a variable that's called output dataset. And what I'm going to store in there is whatever is an input data set. So I'm going to get results from a query of some sort. I'm going to store it into this output data set. It gets stored in this input data set via some stuff under the covers. The input underscore data underscore 1, that's the database query we're going to run. So I'm going to run this on my database, which then gets fed to the R script. And then you'll be able to see the result set instead of just what this is coming back with. This syntax will take a while to get used to. The first time you run an R query and the first time you run a Python query, they may seem slow. It is because it needs to tell machine learning services, hey, wake up. Once it's listening, it's not as slow to run. I've noticed the slowness mostly with the Python side, but once it's going, it's good. Alright, so you can see the results. I look under messages, just one row effective. This is a fairly simple, just what does R look like that. Let's look at our demo, my Python demo, so you guys can see the Python side as well. Okay, there's Python. Python I got a little more carried away with. So the Python demo, basically we're going to do some stuff in SQL, do some more setup in SQL. I'm going to get some data. I'm going to then read in the data. I'm going to do some Python things. After I'm done with the Python things, I'm going to output some stuff as well. So basically, I've got some things going. Let's take a look at the Python so you can see. Python is a tabs or space sensitive language. It makes a difference in here. Do not mix your tabs with your spaces. Choose one or the other and be consistent. That's all I'm going to say. If you ask if I'm tabs or spaces, I don't care. Just make it work. But there's a religion behind that, and I don't want to deal with that. So. Alright, so I have an integer. It's just a parameter integer parameter time, so you guys can see what happens when I have SQL data types. You can see that I'm saying, okay, these are my output parameters, and this is what my data looks like. And what I'm going to do is I'm going to bring in 5 rows per read. Now, once again, we're doing the execute, sp underscore execute underscore external underscore script. Same stored procedure that we use for R. We have this language parameter. Instead of R now, we're calling it Python. My script. So I'm importing my sys and importing my OS. The reason why I'm doing print sys.version is so you can see what version of Python are we working with. So I'm going to say hello world. Just print out hello world. Print out the current working directory. So these are not SQL commands. Because SQL, we're getting into ifs and else's, and they do things differently. So if I change my parameter to one thing, I want it to say that parameter int equals 1. So parameter int, there's parameter int, parameter char n in SQL, parameter char n in here. Got my output data set, global days. So I've got some days of the week, 1, 2, 3, 4, 5, 6, 7, mapped to the days. And then what I'm going to do is I'm going to get a series of the days of the week. So the output data set, day of the week. Let's get the days of the week. We're using pandas. If you're familiar with Python, pandas may seem familiar. Pandas is the library that we use for data science processing. A lot of data munging, data manipulation. And you're going to see stuff like index equals output, data site index. It types in 32. So this is my Python script. I'm going to pull everything from my Python test table. Let's see. Let me see if I can show you what that looks like. Python test. I'm going to browse that so you guys can see what we're looking at. So at the top, 1,000. So right now, my Python test, I have some Sunday, Monday, Tuesday, so I have days of the week. I have some amounts that are associated with the days of the week. Python script again. Then we're going to take a look at these parameters to see. So we have the parameter int and the parameter char that we declared in the SQL before. When we run Python, notice Python had those variables parameter int and parameter char n, which match the SQL Server name variables. What does that look like? So we're going to output that as well. I'm going to double check to see if I have a use statement at the top, just to make sure it's not going to go kaboom, and we're going to go ahead and tell it to execute. Again, this is because I'm just starting with the Python and I didn't run this before you guys came in. It would take it a little bit to get started, but then it kicks over. So if I come into my messages, you can see that we are at my output parameter before. My parameter int is equal to 1, 2, 3, 4, 5, 6, 7. My param char n variable was set equal to input, the word input. My data set before is 10 rows affected, which is in the results.
Sorry, could you put that on the top half of the screen? Be a bit easier to see.
Let's see if it's going to let me undock it. Oh, it's actually going to undock it.
Let's make it taller.
Yeah. We don't care about the SQL so much. Well, I mean, when we talk through the SQL, and I should be able to also zoom it. Is that better?
Oh, yeah.
Okay. Alright, so before we had these parameter int and param char n were declared in SQL Server, in the SQL statement. And then our Python actually had some stuff with a param int and a param char n variable. Does that work or conflict with the SQL? Let's find out. There's our output parameters. Notice our param int is now 2 and our param char n is now equal to output. So, what this allows us to see is that I can have variables in SQL. I'll show you the script. Let's bring the script back. So I have, again, I declared these in SQL, and we printed them out so you can see that this is what those variables are. You can see that format message, print format message. If I come down here, my output, I'm printing the same SQL variables, but I'm actually changing their values within the Python. So your SQL and your Python variables can easily conflict with each other, something to be very well aware of. So if I have a variable I'm working with in my SQL script, and then in my Python I have a variable of that same name, I'm going to step on it. So you don't want to do that. If you don't intend those consequences, name them separately. If you want them to interact that way, which you very well may because you're bringing the two together, then just be aware that that can happen, and this is what it looks like.
You have two completely separate functions.
Mm-hmm.
Other rules and semantic are the same essential script.
Yeah. Yeah, so yeah, I've got two different languages altogether. I have my SQL that's running right in SQL Server, right on the server itself. And then I'm also running Python, which is also running on the server. thanks to the machine learning services part.
And the transition is that execute statement.
The execute statement, yeah, this SP execute external script, that's what we're using to run the code. That's what we're using to run either the R or the Python. It's the same stored procedure, it's just your language and then your script are different as well.
But that's what's packaging the Python within the SQL.
Well, what's packaging it within the SQL, what allows us to run it, that's machine learning services.
Okay.
Yeah, so when you go through a SQL Server 2016 or 2017 install, you'll have options for machine learning services, and they allow you to choose do you want R, do you want Python. Oh, and if you check either one of those, it'll tell you what you need to do to install it. If I remember right, it was a simple download for those as part of the installer for Python. Because the Python setup actually is horrible if you install it separately, but let SQL Server do it, honestly, if you can find it. With the SQL Server, see if I can remember where that's at. There is in our, I believe it's C, program files, x86, Microsoft SQL Server, up there. 14. At that point, I don't remember where Python is. Let's search on that. It's going to be it's in there. I think I have it on one of the slides too, where there's the actual file location. Now, if you're a developer who happens to have Python installed separately from machine learning services, know that your Python install is going to look at one location for your libraries. SQL Server looks in a different location. I think I have that location on the slide deck where you can see where what libraries get packaged with the Python install. Because as I was running my sensors code, it wasn't working at first because there's no ggplot, which is part of the R stuff. So I had to play around with that a bit more as well. You know what, it's 7:30. Let's give you guys about a 5-10 minute break, go to the restroom, get water, and then when you come back, we'll look at this some more.
Very good.